Hello viewers, for any RCC structure, concrete forms the major part of civil construction. The serviceability and durability of any structure depends upon the proportion of the ingredients used in concrete and their physical properties. The various ingredients used in cement concrete construction are cement, aggregates both coarse and fine, and water. One of the important tests on coarse aggregate is determination of its particle size distribution through sieve analysis. In the present video program, we shall see the demonstration of sieve analysis of coarse aggregate for determining its size and gradation. The apparatus used to perform this experiment on sieve analysis include set of sieves, weighing balance, enamel tray, scoop and pan, and sample of aggregate under test. Here, the sample of coarse aggregate under test is of approximately 20 mm size. So, the sieves used are 20 mm, 16 mm, 12.5 mm, 10 mm, and 4.75 mm with pan at the base and lid at the top. We also need the observation sheet to record the readings. This observation sheet has column 1 for sieves of sizes 20 mm, 16 mm, 12.5 mm, 10 mm, 4.75 mm with pan at the base. Column 2, 3 and 4 will be used to record the fraction of aggregate weight retained on different sieves for 3 different samples. An average of 3 determinations of fraction of weight retained shall be recorded in column 5. From the value recorded in column 5, percentage of total weight retained will be calculated and placed in column 6 for individual sieves. Column 7 is used to fill the cumulative percentage of total weight retained. Percent passing of coarse aggregate is finally recorded under column 8. During the conduct of the experiment, different weights retained on different sieves will be recorded in the observation sheet and final calculations are made to find out the size and grading of the aggregate. To start with the experiment, take 1000 grams of coarse aggregate sample. Enter this reading in the observation sheet. Now place the sample in the set of IS sieves already arranged in order with 20 mm sieve at the top and 4.75 mm sieve at the bottom. Shake the complete assembly by giving varied motion so that each particle gets sufficient chance to pass through the sieve opening. After proper sieving, fraction of aggregate of different sizes will be retained on different sieves. In this sample, as we see, no aggregate is retained on 20 mm sieve. Firstly, the weight of the fraction passing through 20 mm sieve and retained on 16 mm sieve is measured. Similarly, the weight of fraction passing through 12.5 mm sieve and retained on 10 mm sieve, and also the weight of fraction passing through 10 mm sieve and retained on 4.75 mm sieve are measured and recorded. Repeat the procedure, taking two more representative samples from the same lot and record the observations in the same sheet. After having recorded all the weights retained on different sieves, further calculations to determine the size and gradation of coarse aggregate sample is made. Now, let us see how do we use these values to determine the percentage weight retained, the cumulative percentage weight retained, and percentage passing, which is finally compared with the permissible values given in IS 383. From the observed values, first of all, the average weight retained for 3 samples is calculated and placed in the observation sheet. In this case, for 20 mm sieve, it is 0. For 16 mm sieve, it is 47.3 grams. Likewise, an average weight retained on 12.5, 10 mm and 4.75 mm sieves are calculated and placed under column 5. The percentage of total weight retained on individual sieve is equal to the weight of the fraction retained divided by the total weight of the sample taken and multiplying it by 100. For 20 mm sieve, it is 0. For 16 mm sieve, it is 4.73%, and for 12.5 mm sieve, it is 49.40%. Likewise, for 10 mm and 4.75 mm sieves, the values are calculated and placed in the observation sheet. Similarly, the percentage weight retained on each sieve is calculated and recorded. Cumulative percentage of total weight retained on a sieve is calculated by adding the percentage weight retained on the preceding sieve to the immediate succeeding sieve. In this case, cumulative percentage weight retained on 20 mm sieve is 0%, on 16 mm sieve it is 0 plus 4.73%, which is 4.73%. For 12.5 mm sieve it is 4.73 plus 49.40, which comes out to be 54.13%. For 10 mm sieve it is 54.13 plus 37.47, which comes out to be 91.60. Likewise, cumulative percentage is calculated for 4.75 mm sieve and for pen. Lastly, percentage passing through each sieve can be calculated by subtracting the cumulative percentage weight retained on individual sieve from 100, and the value is placed under column 8. The percentage passing so obtained shall then be compared with the permissible values given in table in IS code 383. The standard table in the IS code shows the permissible value of percentage passing for single sized and graded aggregate. Size of aggregate, whether single or graded, can thus be determined by comparing the observed values with the permissible percentage passing given in the code IS 383. In this case, on comparing, it can be concluded that the aggregate corresponds to 20 mm single size. In this video program, you have seen the demonstration of sieve analysis of coarse aggregate and also the procedure involved in making calculations for finding the percentage passing on different sieves. You have also seen the standard table showing the permissible values of percentage passing as given in IS 383. Since the grading of the aggregate greatly influences the cohesiveness of the concrete mix, therefore it is important that the correct experimental procedure as per the relevant Indian Standard Code should be followed. After having viewed this video program, I am sure you must be able to perform this experiment in the laboratory.